Hello students, welcome you again. Today we are going to discuss about the filter design FIR, in which frequency sampling method is very important. Previously, two methods were discussed in the classroom. The first method was Fourier series method. The second method was windowing techniques. The final frequency sampling method is also very important for the university examination. Today we will discuss about the frequency sampling method with one worked example. Right. Here is the example. FIR filter design using frequency sampling method. Consider a filter with desired frequency response as below. So the problem given with the desired frequency response expressed in Hd of e power j omega. Here they have directly given the value of Hd of e power j omega e power minus j 3 omega. So from this example, few points to be observed before proceeding. First point is whether the HD of e power j omega is directly given or it is given with the alpha value. You know the formula for alpha. Alpha is n minus 1 divided by 2. N or m both are representation for the length of the samples. Don't worry about the representations. Idea is number of samples is given or not. Here it is represented as m, so don't confuse yourself. And then second point is it is very between the few periods, that is here 0 to pi by 2. You know that your frequency response will vary from minus pi to plus pi. So within this, your the given frequency response is vary from which area. Here in the problem 0 to pi by 2, right? And then pi by 2 to pi is the 0. Okay. And then another point to be observed here is whether it is given with the type 1 design or type 2 design. So 90% of the question will be focusing the type 1 design. So don't worry about the type 2, I will teach you later. Okay, right? Your desired frequency response is given here with the period of 0 to pi by 2, and then number of samples are 7 with the type 1 design. Okay. So as I said, your frequency response will vary from minus pi to plus pi. And then from this graph, you have to understand your signal is periodic in nature. You might have studied in the signals and system in the previous semester. Periodic signal would repeat the signal with some period. Here it is repeating from minus pi by 2 to plus pi by 2, and then again it is 3 pi by 2 and some extent. Okay. So the value given in the previous slide are 0 to pi by 2. Your desired frequency response is available only in the e power minus j 3 omega. So it is 0 to pi by 2 here. We know that symmetry conditions and as well as periodic conditions. So since it is a symmetry condition, your value will be vary from minus pi by 2 to plus pi by 2. Already I have told in the classroom. So if you fold this 0 to pi by 2 to the left hand side, you will get the remaining part, that is symmetry part. Okay. And then you have to observe here the new point is periodic in nature of the signal, right? This signal is repeated after this way 3 pi by 2 to and so on, right? So you should not forget to draw the frequency response diagram during the examination. Okay. So hd of e power j omega is given, and then we have to convert h of k. H of k is the DFT value, and then finally we go for a coefficients h of n. So our ultimate aim is to identify the h of n. right? So H2 of e power j omega is given. We already seen in the previous slides. Now I'm going to talk about the FAR value. Sorry, DFT value. Right. Here the DFT, to convert our value to DFT values, we have omega k equal to 2 pi by n, 2 pi k by n. Okay. So here omega k is equal to 2 pi k by n. So this is the symbol of DFT values of your HT of e power j omega. So this omega in HT of e power j omega will be replaced with the omega k value. So we know that n value or m value is 7, and then here in this problem we have to identify the value of h of k. Your e power j omega will be appeared in the which location? It's very important. So for that you just take this 2 pi k divided by n, right, and then apply k equal to 0 to 6. Here k equal to 0, your value may be omega k equal to 0, and k equal to 1, your value will be omega k equal to 2 pi by n, that is 7. You can take degree value or radian value, that is not a problem here. Take care of the calculator to identify the radian mode and then degree mode. If you follow the degree mode, don't mingle with the another values, right? So you have to concentrate this area. Keep your calculator always in a radian mode for the DSP. That is my suggestion, right? Here 2 pi divided by 7 value will be appear between the 0 to pi by 2, and then when you substitute k equal to 2, your omega k value will be beyond the pi by 2. So up to k equal to 2, 3 and 4, 5, your value will be equal to 0 from this graph. See, pi by 2 to pi. So if you identify, if you put it in the calculator, you can easily understand the k value from 2 to 5 will be between pi by 2 to 3 pi by 2. Okay. So after this, when you substitute k equal to 6, 12 pi by 7 will be appeared between 3 pi by 2 to 2 pi in this location. So since it is your signal frequency response is periodic in nature, so you have to consider up to 6, right? K equal to 6. So your signal will be available at k equal to 0, 1 and 6. This is very important point. And here it is written as e power minus j 6 pi by k divided by 7 will be appear k equal to 0, comma 1 and then 6. Very important. This could be very new to you. Please make a note on this. Okay. And then remaining parts are very easy. After finding this h of k, your as I said, hd of e power j omega is given, and then you found h of k value, and then immediately go for h of n. This h of n value will be taken by taking the inverse of this h of k, that is IDFT. The formula is 1 divided by n, k equal to 0 to n minus 1, hk, that is this value, and then your e power j again. You can also substitute or use this formula also. So both the formulas are same, no issues, right? After substituting these values, right, so you will find the coefficients. So you can observe here, with respect to these three, your value will be repeating, since h of n is equivalent to h of capital N minus 1 minus n, symmetry condition, right? Observe here, h of 2 and h of 4 will be the same, h of 1 and h of 5 will be the same, and then h of 0 and 6 will be the same, right? So once you find these little coefficients, So go for finding the h of z and then draw the relation, linear phase relation. Okay. If you have any doubts, please comment on this. Thank you so much. We'll meet you again.